standing in a sunroom right now that many of you have seen me in because I often am in class during this time. Sunrooms are called sunrooms because they have so many windows they let in sunlight from everywhere. Well, one of the reasons that they designed it this way is because of something called the greenhouse effect. Greenhouses, like sunrooms, are made of a ton of glass. And when sunlight goes through glass, it heats up the air particles in that room. Well, when you heat up those air particles, but you trap those air particles, then the energy from that heat stays in there too. So the rays of the sun, like little laser beams, zap those particles and then cause them to vibrate. And that vibration has energy, and that energy makes you feel the heat. The space between those particles grows, and they start to bounce against your body, and you feel warm. Well, that allows this sunroom to actually be at a totally normal temperature, even when the outside temperature is really, really cold. The greenhouse effect is how this happens in an entire room or a larger scale, where something is trapping the heat that's coming from the sun. Well, there's another thing that can trap that heat, and that's our atmosphere. Our atmosphere has tons of gases in it, including water vapor, nitrogen, oxygen, carbon dioxide. Some of those gases are like the glass in this room. They can trap heat when the heat is in there. You have enough of those, then we actually wouldn't survive without them, because we need to feel a little bit warm, especially at night. In a planet like Mercury, a place like the moon, when it's night, there's nothing holding in the heat anymore from the sun, and so it drops to freezing cold temperatures. Mercury is boiling hot in the day and freezing cold at night every single day for the entirety of the year. But for us, at nighttime in the summer, there's plenty of heat left over because it's trapped by our atmosphere. The problem is when you have too much. In a room like this, it can get incredibly hot in the summer because the sun is shining for so long and the glass holds all that heat in. So you feel like it's 80, 90 degrees in here. Well, that's no good. We need to let some of that out. We need to open a window. We don't have windows in our atmosphere. We have the glass we have, the gases we have, and if we have too much, then too much heat gets held in and you start to feel the climate getting warmer. Behind me is the greenhouse of the Indianapolis Botanical Gardens. If you've never been, the Botanical Gardens have a butterfly garden and tons of plants that are not native to this area of the world. Tropical plants, desert plants, some that require a lot of moisture, some that require very little moisture. And the reason this is possible is because it's in a greenhouse. The greenhouse effect is so strong that it can capture rays of sunlight and heat that light creates and hold it inside of the glass. Even though you can see outside and the outside air is cold, the inside stays very warm, even when right now it's so cold that I'm basically slurring my words. It's like 30 degrees outside. But those plants are in 80-degree heat, very humid, very nice, and tropical plants that would normally be at the equator are able to survive in Indianapolis all year long. In our atmosphere, the greenhouse effect plays the same role. Atmospheric gases like water vapor, as well as carbon dioxide and a couple of other gases you'll find in there that are not as big, they're going to trap heat from the sun and they'll bounce around underneath it where we're breathing and living so that we feel the warmth from the sun. Greenhouse gases are any gases in the atmosphere that can basically trap heat from the sun. Most of the time this is invisible. The one visible greenhouse gas that we see is water vapor, and while we can't actually see the vapor all the time, we can see the clouds that are there, and those are liquid droplets where they make these nice puffy white clouds that can also trap heat. Most of the greenhouse gases in our atmosphere are naturally occurring, like that water vapor, as well as a lot of the carbon dioxide that comes from animals just breathing out. And it's actually good that we have some greenhouse gases, because if we didn't have anything holding in heat, we would be freezing cold all in the nighttime, and especially in the time of the year where we don't have a lot of sunlight. So we need some. The trouble is that when you have a little bit extra, more heat gets trapped, and that heat can't really get released anywhere, and that has effects down the line. Now, one of the most common sources of atmospheric carbon dioxide and other greenhouse gases is our cars. These tailpipes release as a waste gas all of the carbon dioxide that comes from burning the fuel that's inside of our fuel tank, as well as some other gases that can be pollutants. Carbon dioxide isn't dangerous to us to breathe in the way other polluting gases are. However, in large amounts, it can raise the amount of greenhouse gases in the atmosphere above what naturally should be there. And when you start to raise that amount, then you can expect the temperature will go up too. What will happen if the temperature goes up? What would happen to water if it started to get a little bit hotter than it normally would be? What would happen to our atmosphere, to our clouds, if there was more water in it? If there's more water in the sky, what are we going to expect to start happening to our weather forecast? Every single time one thing changes, it affects something else down the line. And so this one change that we're creating does have impacts, and those impacts matter. And paying attention to how much we're putting in the sky is going to be a big part of how we fight climate change and prevent that from having massive disastrous effects later down the line. Another common source of greenhouse gases is burning natural gas. We looked at burning petroleum in cars, but natural gas is coming out of that chimney up there. Now, when you burn natural gas, you get two gases that are released in the atmosphere through chimneys like this. One gas is water vapor, and water vapor isn't harmful to anything, but it is also another gas that traps heat. And then the other gas is carbon dioxide, and both of those gases are able to take heat from the sun and keep it from zapping back out into the space. And if you imagine everything in the atmosphere being almost like bumpers in a pinball game, and rays from the sun being like the pinball gets sent down from the sun and then bounces around. If there are more bumpers, it bounces around a lot more before going back out into space. And if there's less bumpers in the atmosphere, then it will bounce back into space a lot faster. Planets like Mercury, places like the moon, have very few bumpers in the atmosphere, so the pinball just goes straight back out. What if you have a whole bunch of bumpers, more than you need? You have a planet like Venus, which has temperatures up above 200 degrees in day and night. Much hotter on Venus than it is on Mercury, even though it's further away from the sun, and that's because of the greenhouse gases in its atmosphere. You can imagine two possible futures for our planet then. One where you have too many greenhouse gases, the terrible place that is Venus, where we tried to land a probe and it got destroyed on impact. Or Mars, where it's basically a barren wasteland. Earth is in the sweet spot where it's got just the right amount of greenhouse gases in our atmosphere that we can have a water cycle because water doesn't get too hot or too cold. We can have enough warmth that we can survive because we don't get too hot or too cold. Plants can grow without freezing because it doesn't get too hot or too cold. Just like the porridge in Goldilocks, we call this the Goldilocks zone. It's just right, just far enough away from the sun that it doesn't get too hot or too cold for water to be able to cycle through and for all of life to be able to survive.